Forces in circular motion, so we're back to drawing free body diagrams. So let's do a quick review of our new pattern we're going to have to do for circular motion type force problems. So we're still drawing that free body diagram. It's just we also have to identify the direction of that centripetal acceleration, that radial acceleration, as radially inward. It always points from the object toward the axis of rotation, and we have to label it as the positive direction. After that, generate equations and solve. When we generate those equations, we're going to be summing up those forces parallel to the radius, setting equal to MAC, and then we'll end up probably doing some substitutions here for AC, where either it's V squared over R or omega squared times R. Sometimes we'll even do a substitution again with V being the speed, being 2 pi R, the circumference divided by the period. All right, let's take a look at this first example. A small button placed on a horizontal rotating platform with a diameter of 0.32 meters will revolve with the platform when it is brought up to a speed of 40 revolutions per minute. Provided the button is no more than 0.15 meters from the axis, what is the coefficient of static friction between the button and the platform? All right, so they gave me some information in here. First of all, they told me omega was 40 revolutions per minute. So seeing that revolutions per minute, that's my clue that they're giving me the omega value. Also, they said that the distance from the axis of rotation was 0.15 meters. Now, they did give me the diameter of this wheel, but in this case, I don't need it. There's probably a part B that I took off of this question that you probably need that for. All right, now we need to find the coefficient of friction. So that's going to be hiding in the force of friction. So that means I'm going to need a free body diagram. So I start drawing my forces on here. Well, I have gravity acting straight down, mg, and I have normal force acting up. And I also have friction. Now, the direction friction acts here. And if I think about a car, so if I have my car and I'm driving down a road and it takes a turn, if there's no friction, I'm going to go in a straight line into the ditch. So friction allows me to turn the corner. And whenever the force is perpendicular to that velocity, it's going to cause it to change directions. So we want that force to cause a centripetal acceleration and change the direction of motion. Because remember, that's what AC tells us about. So that means that the force of friction is acting radially inward. Now, remember I gave you the example of a car going around a corner. This is the same free body diagram that you're going to have for a car moving around a corner, okay? All right, so I've drawn my free body diagram. I need to identify the direction of AC. AC always points radially inward, and I need to label the direction of the acceleration as positive. That way I have a positive acceleration when I plug that number in. All right, so next I need to generate my equations and solve. So I'm going to sum up the forces parallel to the radius and set it equal to MAC. So parallel to the radius, I only have the force of friction pointing radially inward in my positive direction equals MAC. Now we were asked to find the coefficient of friction, which is inside that force of friction. So we have mu times the normal force equals MAC. Oh my, they didn't give me the mass. I'm done. Don't worry, keep going. Guess what's going to happen to that mass? Yep, it's going to cancel for us. So I want to find normal force. Okay, so how am I going to find normal force? So this is just like before. I'm going to sum up the forces in the y direction. It's going to be 0. My button is not accelerating off of the platform or into the platform. So I have normal force minus mg equals 0. So the normal force equals mg. Make that substitution over here, and yes, your wishes come true. The masses will cancel. Now for centripetal acceleration, since they gave me omega, I'm going to make a substitution that the centripetal acceleration is omega squared times r. Okay. Again, my masses do cancel here. We're solving for mu, so mu is going to be omega squared times r divided by g. One extra little bit before we plug in our numbers is we got to make sure everything's got compatible units. So the radius, 0.15 meters, acceleration of gravity, 9.8 meters per second squared. However, this is in revolutions per minute. Omega needs to be in radians per second. So we're going to have to go ahead and make that conversion here. So I have 40 revolutions per minute Get rid of revolutions, go to radians, so I'm going to be multiplying by 2 pi. Get rid of minutes, go to seconds, so I'm going to be dividing by 60 to get that omega value. Go ahead, find omega here. You get an omega of 4.19 radians per second. Plug those numbers in down here, and so I have my 4.19 squared times 0.15, all divided by 9.8 will give you a mu value of 0.27. It should come out positive, and it should be a number somewhere between 0 and 1, and you'll even remember there's no units.